Okay, hi, Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to everyone. Okay, so welcome back to my class. Okay, so for this week, we are going to learn a new chapter, okay, which is chapter 5, circles. Okay, so in this chapter, circles, we are going to learn three things. Okay, basically. Okay, the first one, you're going to learn about the properties of a circle, and then you're going to learn about symmetrical properties of chords. The last one, you're going to learn how to calculate the circumference and area of a circle. Okay, and this is some of the word link that you can find in this chapter, where this is the English words, English term, and this is the translation in Malay. Okay. Okay, now, so let's look at our first learning standard for today, so which is recognize parts of a circle and explain the properties of a circles. Okay, so I think everyone knows what the circles look like, right? Okay, but okay, so actually there are certain things of the properties of circle that you need to know. Okay, some other criteria. Okay, so let's look at the parts of a circle. Okay, so let's look at the first one. Okay, the first part of circle, we call it as radius. So what is radius? Okay, so radius is a straight line. Okay, a straight line from the center of the circle to any point on the circumference. Okay, so over here it mentioned about center and circumference. So let's look at what is center and what is circumference first. Okay, so center. Okay, center is a fixed point where all points on the circumference are equidistant. Okay, so yang tengah-tengah ni, the middle part is what we call center, where when we connect any point from the center to the circumference, okay, it will be equidistant, okay, each other. So for example, this is 5 centimeter, this one also 5, and this one also 5. Okay, so next, okay, let's look on circumference. So what is circumference? So circumference is actually a perimeter of a circle. Okay, ukur di luar ini. So itu adalah what we call circumference. Okay, so now let's look back at the radius. Okay, it says that a straight line from the center of the circle, so this is the center of the circle, to any point on the circumference. So this is actually a radius, and usually we label it with small r. Okay, so next, okay, what is a diameter? Okay, a diameter is actually a straight line that touches the circumference through the center of the circle. Okay, for example, we have this part over here and this part over here on the circumference, and we connect both of the dots through the center. Okay, so this is what we call a diameter. You must remember that diameter must go through the center. Okay, untuk diameter dia mesti melalui center. Okay, kalau awak tengok di sini, okay, if you look over here, okay, what is the relationship between diameter and radius? So we know that, okay, this first part is r, radius. This part is also a radius, right? So we can say that, okay, diameter is also equals to 2r. Okay, so we can look at example later in the video. Okay, next look at chord. Okay, so what is a chord? Chord is a straight line that joins any two points on the circumference. Okay, for example, okay, this one, okay, any 2 points on the circumference, we join the 2 points, so it can be called chord. Okay, so let's look chord and diameter. Okay, the definition is almost the same. Okay, a straight line touches the circumference through the center of the circle. Okay, we know that it connects 2 points on the circumference, but going through the center. This is diameter. But the definition for chord is a straight line that joins two points on the circumference only. It didn't mention through the center. Okay, so what is the relationship between diameter and chord? Okay, actually diameter is also a chord. Okay, di mana dia memenuhi syarat chord. Okay, di mana bila kita ada dua titik di atas circumference, kita sambung, okay, itu adalah chord. So we know that diameter is also a part of a chord. So okay, let's look over here. Tips. Okay, diameter is the longest chord in a circle. Okay, next, okay, let's look at arc. So what is arc? Arc is a part of the circumference. Okay, tadi kita tahu circumference is lilitan bulatan. Okay, circumference, okay, perimeter, okay, and then, okay, part of the circumference. Okay, so over here we can see that there is a minor arc and major arc. Okay, so what is the difference between these two things? Okay, minor, okay, we know that minor adalah kecil, major adalah besar. Okay, so maksud dia, when minor arc, okay, it is the smallest arc, smallest part of the circumference. Okay, luar ini sahaja. Okay, and then major arc, okay, major arc is yang besar, maksud dia perimeter yang besar. Okay, major arc. Okay, next. So far, okay. Okay, next, look at sector. So what is sector? Sector is the region enclosed by two radii and an arc. So it mentioned two things over here, two radii and an arc. Okay, so two radii means two radius. So we have the first radius over here, first radius, second radius. So two radii and an arc. So before this we learned two arcs. There are two arcs, minor and major. So over here let's label our arc. Use green. Okay, so this is the minor arc. Minor arc. This is major arc. Major arc. Okay, so what is the relationship between the minor arc and minor sector? So what enclosed in the minor arc is, we call it minor sector. Okay, and whatever enclosed inside the major arc, we call it as major sector. Okay, boleh So saya harap pelajar-pelajar boleh bezakan apa minor arc, apa minor sector, apa major arc, apa major sector. Major arc, okay, yang di luar dia sahaja. Okay, kalau minor sector pula, sector itu macam pizza tu. Okay, kalau arc tadi ingat di luar dia sahaja, dalam dia tak masuk. Kalau minor sector termasuk yang dalam tu sekali, macam a slice of pizza. Okay. Okay, and the last one is segment. So what is a segment? Okay, segment is actually the region enclosed by a chord and an arc. Okay, so kita tahu tadi a chord is a straight line dan menyambung dua point on the circumference kan. Okay, kita potong. Contoh potong. So ada dua bahagian. There are two segment, the small one and the big one. Okay, we know that small we call it as minor. So this, the red one is minor sector and the large one is major segment. The red one is minor segment and the big one is major segment. Okay, so I hope it's clear for you about these 9 parts of a circle. Okay, next, okay, let's look at the first example. Okay, example 1, identify the following parts of a circle. Okay, so there is a B, C, D, E, F. Okay, so let's look one by one. Okay, A. Let's use blue. Okay, A. So where is A? Okay, this is A. So there is a straight line that connects 2 points on the circumference. Okay, so A is what we call as chord. Okay, next B. B is, okay, you have 2 points on the circumference and it connected by a line that go through a center, the center. So B is what we call diameter. Next C, okay, C is a straight line. Okay, a straight line from the center to the circumference. Okay, so we know that it is a radius. Okay, A, B, C. Next is D. Okay, D. So this is D. Okay. Okay, we know that this is a part of the circumference. Okay, so we can call it as D. Okay, so there's no arrow, right? So D, we can assume it is the whole things. Okay, so D is a circumference. Okay, next E. Okay, E, it's look like a slice of pizza, right? So a slice of pizza, we can call it sector. Okay, and final one is F. Okay, F is a part of the circumference, so we can call it as arc. Okay, so I hope you can able to identify the parts of a circle. Okay, so let's continue with our next learning standard. Okay, so in this learning standard, okay, you can verify and explain that diameter of a circle is an axis of symmetry of the circle. Okay, a radius that is perpendicular to a chord bisect the chord and vice versa. The third one, perpendicular bisector of two chords intersect at the center. Number 4, chords that are equals in length produce arcs of the same length and vice versa. And the fifth one is chords that are equal in length are equidistant from the center of the circle and vice versa. Okay, so let's look at the first features. Okay, so over here you can see that, okay, the diameter of a circle is the axis of symmetry of a circle. Okay, so it's true. Okay, contoh kalau awak ada bulatan, okay, kita buat ini sebagai dia punya diameter. Okay, what is axis of symmetry? Axis of symmetry adalah something yang can divide things into two equal parts. Okay, betul tak? Okay, so contoh kita ambil di sini, awak lipat lah. Awak lipat, dia memang akan terbahagi dua dengan sama rata. Okay, any diameter that you select, when you lipat the things, okay, it will give you an equal area. Okay, so we can say that the diameter of a circle is the axis of symmetry of the circle. So this is the first one. Okay, and the second one, a radius which is perpendicular to the chord bisect the chords. Okay, for example, apa maksud dia? Okay, kita ada chord. Okay, for example, okay, saya zoom Okay, for example, you have a chord over here. Okay, and you have a radius. Okay, so when these two things intersect, it actually produces a 90 degrees angle over here. So that is why we call it as perpendicular to the chords. Okay, and bisect. Apakah itu bisect? Okay, bisect means, okay, it divide the things into two equal length. Okay, maksud dia, dia memotong dan membahagikan dua chord ini menjadi sama panjang. So that is what it means by perpendicular to the chord bisect the chords. Okay. Okay, next. Okay, perpendicular bisector of the chords meet at the center of the circle. Okay, it means, okay, when you have two different perpendicular bisector over here, okay, okay, the simple words lah, okay, perpendicular is anything that intersect and create an angle of 90 degrees. Okay, bisector is something that divide into two parts, equal parts. Okay, so for example, you have a bisector over here, perpendicular bisector. Okay, 90 degrees, okay, perpendicular bisector, two equal parts. And then you also have over here, okay, bisector 90 degrees and two equal parts. Okay, so when you panjangkan garis ni and you panjangkan this garis, look, it is intersect in the center. Okay, boleh. Okay, next, equal chords or chords of the same length produce arc of the same length. Okay, maksud dia, okay, for example, you have this chord panjang 5, for example, panjang 5, and you have this arc panjang 7, for example. If this chord is 5, okay, it means this arc, okay, is also 7. So if you have the chord of 5, okay, and then you produce a length of 7, if you have another chord with equal length of 5, it will also produce an arc with length of 7. Okay, itu maksud dia. Okay, the next part is, okay, equal chords are equidistant from the center of the circle. Okay, equal chord ini maksud dia, kalau kita ada chord yang sama ni lah, okay, yang sama, okay, kita sambung kepada center, okay, dia akan sama panjang. Equidistant from the center. Equidistant ni maksud dia sama panjang. Okay, boleh? Okay, so now, okay, actually this part, okay, if you get a question that looks like this, okay, usually you must integrate what you have learned before, which is Pythagoras Theorem. Okay, do you still remember Pythagoras Theorem? 90 degrees, you have A, B and C. Okay, the longest one is hypotenuse. Okay, and how to find hypotenuse is C square is equals to A square plus B square, and you want to find C, you square root A square plus B square. So you need to remember this thing. Okay, so you must remember. Okay, okay, so let's look at the second example. Okay, what is the question? Okay, the diagram above shows a circle with center O. Okay, check betul, center O, and the line MN. Okay, MN is a line which is a chord. Okay, betul kan? Okay, name the axis of symmetry of the circle. Axis of symmetry. We know that axis of symmetry is actually, okay, I highlighted. Axis of symmetry is actually a diameter. Diameter of the circle, betul? So cuba cari diameter dia. So the circle have two diameter, which is AOB. Okay, so AOB and POQ. Okay, so POQ. So that is the axis of symmetry of the circle. Okay, next B. Given that OK. So OK is 3, and then NK NK. This is NK. So NK is 4. 4. So the question is, calculate the length of ON. So what is ON? So, okay, I zoom it. Okay, so if you look at this triangle, so it's look very familiar that from what you have learned before. Okay, so I redraw the diagram. Okay, I redraw it over here. Okay, so I have, this is O, this is K, this is N. Okay, where OK is 3, KN is 4, and the question asks us to find ON. Okay, so to make it easier for you, we can label it as A, B, and C. Okay, so the question asks us to find C. Okay, so we can write it as C square is equals to A square plus B square. So C is equals to square root of A square plus B square. So C is square root of A is 3 square, B is 4 square. Okay, so square root of 3 square is 9. Okay, 4 square is 16. So 16 plus 9 is 25. Okay, so square root of 25 is 5. Okay, so we know that ON, so ON is equals to 5 centimeter. Okay, and C, name the angle that is equals to ONK. So where is ONK? So okay, I padam this one. Okay, so ONK, this one. So what is another angle that is equal to this one? So we know that radius have the same length, right? So it will produce a segitiga sama kaki. Okay, am I right? Okay, what is segitiga sama kaki in English? Segitiga sama kaki is isosceles triangle. Okay, so if you have isosceles triangle, you know that the two angle on the kaki, what we call it, if you have two angles, okay, on the lower parts of the triangle, it is actually equal. Okay, so we can say that, okay, C, okay, angle O and K is actually equals to angle OMK. Okay, okay, next, okay, let's look at example 3. Okay, the diagram on the right shows a circle on the radius OP. Okay, so we have radius of OP that is perpendicular to the chord MN. Okay, MN. Okay, is the length MS equal to the length SN? Explain. So if is the length of MS equal to the length of SN? Okay, so we know that it should be equal, right? So we can say that yes, MS is equals to S, and why? Because, okay, the radius OP is perpendicular to the radius OP is perpendicular to the chord MN. Okay, next B, if the radius of the circle is 10 and OS is 8, calculate the length of chord MN. Okay, so let's zoom in. Okay, it says that the radius is 10. So radius is O until P. So 10. So over here is 8. So balance is 2. Okay. What is the length of chord MN? Okay, so let's draw this triangle first. So triangle. So this is O, this is S, this is M. So OS is 8, OM is 10, MS is unknown. So we know that the chord MN is 2 times MS. So MS is equals to MN. So we need to find MS first, okay? So to make your life easier, just label it as A, B, C. Okay, now we want to find B. Okay, so B square is equals to the longest side is C square minus A square. I hope you still remember what you learned in Form 1, okay, Pythagoras Theorem. So B is equals to square root of C square minus A square. Okay, so B is actually equals to square root of, okay, C is 10, 10 square is 100 minus A is 8, 8 square is 64. So take out 64 from 100. 100 minus 64, you will get 36. So square root of 36 is 6. Okay, so MS is 6. So MS is equals to 6 centimeter. So the question asks total of MN. Okay, so MN is equals to 6 plus 6 equals to 12 centimeter. Okay, I hope you understand the explanation. Okay, next, okay, let's look at example 4. The diagram on the right shows the equal chord RSTU equal length. Okay, POQ is a straight line passing through the center of the circle. Given that OP is equals to 5. OP, okay, I zoom in a little bit. Okay, OP is equals to 5. RS is equals to 24. So it means 12, 12. Okay, 5, 12, 12. Okay, calculate the length of PR. So PR. Oh, we actually have done it. Okay, so PR is actually 24 divided by 2, which give us 12. Okay, next B, a minor arc, RMS. Okay, this one, minor arc, RMS. Okay, and T and U equal in length. Explain. We know that these two minor arcs should be the same. Okay, we can say that yes. Okay, because chords that are equal in length produce arc of the same length. Okay, I already explained to you previously. Okay, if you have the chord, okay, and another chord with the same length, okay, the produces arc are also the same in length. Okay, so the last one, C, calculate the radius of the circle. Okay, so radius, okay, I zoom in. Okay, we know that a radius is a line from the center to any point on the circumference. Okay, for example, for this example, I take from the center to R. Okay, like this. Okay. So did you look? There is a small triangle over there. This one, a triangle. So if there is a triangle, it means that you can use Pythagoras Theorem. Okay, so I take out the triangle, I draw it over here. Okay, for example, okay, this is P, this is R, this is O. Okay, RP you have 12, OP you have 5, and you want to find the radius OR. Okay, so to make your life easier, just label it as A, B, and C, no problem. Okay, so the question wants to find C, hypotenuse. So we know that C square is equals to C square is equals to A square plus B square. So C is equals to square root of A square plus B square. Okay, what is the value of A? A is 5, so 5 square is 25 plus B, what is B? 12. 12 square is 144. Okay, so 144 plus 25 is 169. So square root of 169 is 13. So we know that. Okay, so OR is equals to 13. Okay, you can transfer this calculation over here. Okay, because I don't have enough space over here. Okay, so okay, for example 4. Okay, if we don't have any problem, okay, let's continue to the next learning standard. Okay, determine the center of radius of a circle by geometrical construction. Okay, this one you can try it by using your geometrical construction. Okay, you can find many videos in YouTube how to construct this one. Okay. Okay, now, okay, let's look how to solve problems in this subtopic. Okay. A blacksmith was asked to build a round-shaped window frame as shown below. Okay. Okay, so what is a blacksmith? Blacksmith is actually like a tukang besi. Okay, a tukang besi. A blacksmith was asked to build a round-shaped windows frame as shown below. The window is 50 centimeter in diameter. So diameter is 50. Okay, what is the radius? So radius is half of the diameter, so 25. 3 iron rods PR, US, and QT that are not equal in length are used to support the window. Calculate the length of PR. So PR. Okay. Okay. So I zoom in a little. Okay. So first we know that the radius is 25. So radius is from O until R, right? Okay, so this is radius. So the radius is 25. Okay, so what else can I get from the diagram? Okay, so over here, okay, this is 48. We can divide it into two parts. Okay, so 48 divided by 2 is 24. So over here is 24. Here is 24. Okay. What else can I get? Okay, so I think that's all. Okay, now the question asks us to find PR. So PR, so this is PR. Okay, so from this diagram you can see that there is a small triangle over here. Okay, so I try to draw it. Okay, so like this. So this is OQR. So this is 25. Okay, am I right? Okay, so QR we want to find. Okay, but we don't have the length for OQ. Over here we don't know, so OQ don't know, so we cannot solve it yet. So let's look at this part. Okay, so this part, so this one can be the radius, so which is 25. And then, okay, so we can find OT, right? Okay, so find OT first. Okay, so I draw this part. Okay, so this is 24, 25, and OT, I don't know what is the length. So let's find OT. Okay, so this is A, this is B, and this is C. We want to find A. So A is equals to square root of 25 square minus 24 square. Okay, so 25 square is 625. Okay, actually you can calculate directly in your calculator. Okay, but I want to calculate one by one to make it clear to you. Okay, so 625 minus 576 is 49. Okay, square root of 49 is 7. So over here is 7. Okay, so I know that QT is 31. Okay, and OT is 7. So what is the length of OQ? So OQ is actually 31 minus 7. Okay, which give you 31 minus 7 is 24. Okay, so over here is 24. Okay, so let's go back to the first triangle. So this is 24. Okay, oh, let's look over here. It's the same, right? 24, 25, unknown. 24, 25, unknown. Okay, so which means QR is 7. Okay, so QR is 7. So if this is 7, the next part is also 7. Okay, so our conclusion, so PR is actually equals to 7 plus 7. You will get 14 centimeter. Okay, as simple as that. Okay, the clue is you must use Pythagoras Theorem. So in order to be excellent in this chapter, you need to be excellent in Pythagoras Theorem. Okay, next